So, you hear this word thrown around all the time, right? Database. As behind everything, your apps, your online shopping, pretty much your entire digital life. But what even is it really? Well, today, we're going to break it all down.
All right, let me start with a question for you. What could a simple, scribbled-down shopping list and a massive global giant like Amazon.com possibly have in common? I know, it sounds kind of weird, but the answer is surprisingly simple.
Believe it or not, they are both databases. Yeah, that's the big secret. At its very core, a database is just any collection of related information. That's it. It's a concept you're already using every single day without even thinking about it. Just think about it for a second. They're literally everywhere. Your shopping list? That's a database of things you need to buy. An old phone book? A database of names and numbers. Your to-do list? The comments on this video? Heck, even the list of your best friends that you keep in your head is a kind of database. See? You're already a pro at this. Okay, but here's where things get interesting. A shopping list on a piece of paper, or your friends' names in your mind, that works just fine for a small amount of information. But what happens when that scale just completely explodes?
And this is where that comparison really comes to life. Your shopping list might have, 20 items? Amazon has trillions. If you lose your shopping list, it's annoying, it's an inconvenience. If Amazon loses its data, it's an absolute catastrophe. And you're probably not too worried about someone hacking your grocery list. But Amazon, they have to keep millions of credit card numbers totally secure. You just can't manage that kind of operation on a piece of paper.
And that is exactly why we need computers. When it comes to handling these huge, super important, and highly secure collections of information, computers are the perfect tool for the job. They're incredibly fast, and they are built to manage just massive amounts of data without breaking a sweat.
Okay, so we get why we need computers for these modern databases. But how do they actually pull it off? How does the Amazon app find your one specific shipping address among trillions and trillions of other pieces of data?
Well, they do it using special software called a database management system, or DBMS for short. And honestly, the best way to think about a DBMS is to picture a super efficient digital librarian. It's not the library itself, that's all the data. The DBMS is the expert librarian who knows exactly where every single thing is, keeps it all safe, and can grab whatever you need in a split second.
Let's put our digital librarian to work. Imagine you click Buy Now on Amazon. The app itself doesn't just go digging through all the raw data. No way. Instead, it sends a neat little request to the DBMS, our librarian. The DBMS then securely finds your address, confirms your payment info, updates the product inventory to show one less item, and then reports back to the app, all good, the transaction is complete. The app never touches the data directly. It just talks to the librarian.
And this quote really sums up the job perfectly. The DBMS is the dedicated piece of software that handles all the important actions, creating new information, maintaining it, updating it, and of course, deleting it. It's the gatekeeper and the organizer, all rolled into one.
Okay, so our librarian, the DBMS, is in charge. We got that. But every good librarian needs a system for organizing the library, right? You can't just have books thrown in a giant pile. And for databases, the most common way to organize all that information is with a beautifully simple structure: tables.
And don't let the word tables scare you off. Seriously, just think of a simple spreadsheet, like something you'd make in Excel or Google Sheets. If you can understand a basic spreadsheet, you already get the fundamental structure of most modern databases. So here's what that looks like. This is a student table. It works just like a spreadsheet. The columns, you've got student ID, name, and major. Those are the categories of information we're storing. And then each row is one complete record for a single person. So this row right here, that represents one student, Kate, a sociology major, who has an ID number of 2. Simple, right?
But hang on, what happens if we get another student named Jack, and he's also studying biology? How does the database tell them apart? Well, that's the whole job of this student ID column. It's called a primary key. Its only purpose in life is to be a totally unique identifier for every single row. No two rows can ever have the same primary key. It guarantees the database never, ever gets confused.
Now, storing data neatly in one table is useful, for sure. But this next part, this is where the real power of a database comes from. The magic isn't just about organizing information in one spreadsheet. It's about connecting information across many different tables.
So check out this employee table. We've got a unique ID for each employee, their first name, their last name, and then Look at this last column, branch ID. What's that all about?
It connects to this table, the branch table. See, in this table, the branch ID is the primary key, and it simply links that ID number to the actual name of the branch. And that branch ID back in the employee table, that's what we call a foreign key. It is the magic link. It's just a column in one table that happens to be the primary key of another table. This is how the database knows that Michael Scott with a branch ID of 2 works at the branch with the name Scranton. This is how we build relationships between different pieces of data. It's so cool.
So what's the big takeaway here? What does this all mean for you? Well, this basic structure of tables and keys is the invisible engine that powers almost every single app you use every day. Databases organize enormous amounts of information, create these complex connections, and just make our digital world work. Understanding these basics really means you're understanding a core piece of how our modern world is actually built.
So I'll just leave you with this final thought. Now that you understand the basic blueprint for organizing information, from something as simple as a shopping list to a company's massive inventory, what systems in your own life do you think could be improved with the simple, organized power of a database?